Now, there are multiple different types of QKD. In prepare and measure QKD, Alice encodes the key bits into individual photons, sends those individual photons to Bob, and then Bob decodes the photons back into key bits. In entanglement-based QKD, we have a midpoint station that sends pairs of entangled photons to Alice and Bob, and then Alice and Bob each decode their received photons into key bits. And finally, in interference-based QKD, Alice and Bob each send individual photons to a midpoint station, and then that midpoint station performs what is known as a Bell state measurement on the received pairs of photons from Alice and Bob. And then the key bits are produced from these Bell state measurement results. Now, in this seminar, I will describe each of these protocols in more detail. We can also make a distinction between discrete variable QKD and continuous variable QKD. Oversimplifying a little bit, we could say that discrete variable QKD relies on the light behaving like a particle, and continuous variable QKD relies on the light behaving like a wave. Now, both discrete and continuous variable QKD systems are used in practice, but in this seminar, unfortunately, I only have time to cover the discrete variable QKD variation. And finally, there are multiple ways to encode the key bits into the quantum state of individual photons. In this seminar, all of my examples will use polarization encoding because that's the easiest to explain and the easiest to understand. But time bin encoding is also popular, and there are several other less popular, less used encodings.